So my dear students, we had started exercise 6.5 and we had solved the questions up to 6th one. So children, what I am going to do, I am going to solve each and every problem of all the exercises which I am going to take up. Means any chapter we are taking up, a number of exercises are there in that, and almost all the problems which are a few problems which are appearing to be easy, I will skip those problems, otherwise rest of the problems I will be solving on the board and with the proper explanation. So here I will take up question number 7. This is proof that sum of the squares of sides of a rhombus is equal to the sum of squares of its diagonals. Here let us understand first what the rhombus is. Rhombus is such a parallelogram whose all the four sides are equal and diagonals bisect each other at right angle. I'll repeat. It is A, B, C, D is the rhombus. Means A, B, C, D is a parallelogram, and this is such a parallelogram whose diagonals are bisecting. Bisecting means dividing in two equal parts at right angle. So it means AE is equal to CE and BE is equal to DE. Right? This much is clear. So I will proceed further. So I will go for solution. Given, what is given? Given A, B, C, D is a rhombus. It means, therefore, AB is equal to BC is equal to CD is equal to DA or AD. This is the property of rhombus. And AC is equal to 2AE and BD is equal to 2BE. And angle AEB is equal to 90. This is the property of rhombus. As I told you, ABCD is a rhombus and diagonals bisect each other at right angle and all the sides are equal. So since ABCD is a rhombus, this is the result we are getting out of its property, right? So we will consider the triangle ABE. So in triangle ABE, it is a right angle triangle because this angle and this, all the four angles are 90 degree. So this angle is 90 degree. So this is a right angle triangle. Therefore, AB square is equal to AE square plus BE square. How could I write this? We have already studied that in right angle triangle, hypotenuse square is equal to sum of the squares of remaining two sides by Pythagoras theorem. By Pythagoras theorem, we are having this kind of relation. Now we will see AB square is equal to AE. AE is equal to AC by 2. So we can write AC upon 2 whole square plus. Because all the results we have to get should be in terms of sides and diagonals. Because what we have to prove, the sum of the squares of the sides is equal to sum of the squares of the diagonals. So all the results finally what we have to get should be in terms of sides as well as the diagonals. So AE is not a diagonal, so I have written A in terms of diagonal AC. That is AE is equal to AC by 2 plus BE is equal to BD by 2. BD by 2 whole square. Further, therefore, AB square is equal to AC square upon 4 plus BD square upon 4. Squaring these two. So from this we will get, that is AC square plus BD square by 4. Since denominator is same, so we will add the numerator and we will write like this. Therefore, taking 4 on the left hand side, so we can write AB square is equal to this. That is 4AB square is equal to AC square plus BD square. Now, 4AB square, we know that AB is equal to BC, BC is equal to CD, CD is equal to DA. So this can further be written as 4AB. So you will write AB square 4 times. AB square plus AB square plus AB square plus AB square is equal to what? AC plus BD. AC square plus BD square. AB, 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 AB 4 times I have written. Why did I write like this? Reason is 4 sides for all the ABs, right? We can write other sides as well. Therefore, 1 AB square will remain as it is. For other AB, we will write BC, that is BC square plus third one AB, that is equal to CD, CD square plus last AB is DA square is equal to AC square plus BD square. This was to be proved. So we can write, we have proved the relation. Question was this was required, this we have proved. Now we will go for the next question. Question number 8. In figure O, O is the point in the interior of the triangle ABC, and these are the perpendicular as shown, and we have to find this relation. This means we have to prove this relation. Now, from triangle AFO, you see all these triangles are right angle triangles. So we can use the property of right angle triangle, that is Pythagoras theorem can be used over here. So from this triangle AFO, right, from triangle AFO, OA square is equal to AF square plus OF square. AF square plus OF square. Similarly, in this triangle, we will write similarly OB square is equal to OD square plus BD square, and OC square is equal to OE square plus CE square. From these three triangles AFO, OBD and OCE, we have got this relation. Now left hand side will be added and right hand side will also be added, and we will get another relation. Therefore, OA square plus OB square plus OC square is equal to AF square plus OF square plus OD square plus BD square plus OE square plus CE square. We have got this relation now. What is to prove? OA square plus OB square plus OC square minus OD square. This OD will be taken on left hand side, OE will be taken on left hand side, similarly OF will be taken on left hand side, and we will get the relation. Therefore, OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. Because this this and these are transferred on left hand side, and we got these three quantities on right hand side. So therefore this is the relation, and we have got, and it has been proved. Second part, AE square is equal to OA square minus OE square. OA square minus OE square. Similar, CD square. CD square is equal to this part. This is CD square is equal to OC square minus OD square. OC square minus OD square. And finally BF square, that is this one. BF square, that is BF square is equal to OB square minus OF square. OB square minus OF square. Now left hand side we will add, right hand side we will be adding, and then what kind of result we are getting, that we will write. Therefore AE square plus CD square plus BF square is equal to OA square, OA square minus OE square plus OC square minus OD square plus OB square plus OB square minus OF square. And we will rearrange all those. So we will get OA square plus OB square plus OC square minus OD square minus OE square minus OF square. So what do we observe? The right hand side part is this one. Therefore this is equal to this one. That is AF square plus BD square plus CE square. That is from first part. From first part we have got this relation. So finally this is proved. Therefore AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. This is proved. This way we have proved both the parts of this question. It is a very good question, but only rearrangement of the terms is to be done in this. Question number 9th and 10th. These two questions are very easy. Both the questions depend on the theorem, that is Pythagoras theorem, and you can attempt it, you can do it by your own, because two sides will be given, third side is required. Using the formula you can solve those questions. This question, question number 11, is slightly different, so I would like to attempt this question. Question is, an aeroplane leaves the airport and flies due north at a speed of 1000 kilometers per hour. At the same time another plane leaves the same airport due west at the speed of 1200 kilometers per hour. How far apart will the two planes after 1.5 hours? So, if we make the directions like this, north, south, east and west. One plane, from here it starts, it moves towards north. At the same time, another plane leaps towards west. After 1.5 hours, it reaches over here. Suppose this point is A. And after 1.5 hours, this second plane reaches at B over here. Right? So, what is required? This distance, how far apart these are. So, this is distance from O. From here they have moved OA, the distance moved by first plane during the span of 1.5 hours, and OB, the distance moved by another plane. Simultaneously they are leaving, so distance moved within 1.5 hours. These distances will be found, and we will use the Pythagoras theorem, and this is 90 degree, as we know that all the directions from the central point is 90 degree. So, solution. OA is the distance moved in 1.5 hours by first aeroplane. OA, the distance moved by first plane in 1.5 hours, and OB, the distance moved by second in 1.5 hours. Therefore, OA is equal to, speed is 1000 kilometers per hour. So 1000 multiplied by 1.5 hours means it is 3 by 2. That will become 1500 kilometer, and OB is equal to 1200 into 3 by 2, because the speed into time is the distance, right? That is equal to 1800 kilometer. Since distance is equal to speed into time, this should be known to you. So distances are known. So OA is equal to 1500, and this is 1800 kilometers. So AB can be found out by Pythagoras theorem. Therefore, AB is needed. AB square is equal to OA square plus OB square. That is equal to OA means 1500 square plus OB is 1800 square. So this can be done. We can 100 square separately we can take common. That is 15 square plus 18 square into 100 square, because 15 into 100, so 15 square into 100 square, 18 into 100, 18 square plus 100 square, 100 square we have taken common, so this will be the relation we will be getting. 15 square is 225. What is it? 324 into 100 square. So this is 549 into 100 square. Therefore, AB is equal to under root 549 into 100 square. So 100 will come out, we will get 549. We can find the square root of this and multiply this by 100. We will get the how far these aeroplanes are apart. Now we will take up question number 13. What is the question? D and E are the points on sides CA and CB respectively of a triangle ABC right angled at C. It is given ABC is a right angled triangle where angle C is 90 degree. Then prove that AE square plus BD square is equal to AB square plus BE square. This is to be proved. So we will go for the solution. Here we will see in the right angle triangle AEC. In triangle AEC, since it is 90 degree, AE is the hypotenuse, therefore AE square is equal to AC square plus CE square. Similarly, if you take this triangle, then BD square is equal to BC square plus DC square, because BCD is also a right angle triangle where C is 90 degree, then BD is the hypotenuse, So hypotenuse square is the sum of the squares of remaining two sides, that is BC square plus CD square, that I have written. Now equation number 1 and this is equation number 2. Adding 1 and 2 means we will write from 1 and 2. Add these two, you will get AE square plus BD square is equal to AC square plus CE square plus BC square plus DC square. We will rearrange the terms on right hand side. So we will write AC square plus BC square plus CE square plus DC square. Why did I make this kind of arrangement? Because what do we observe? That AC square plus BC square is equal to AB square, because ABC is a right hand triangle. So if these two are taken together, AC square plus BC square, then these two terms can be written as AB square. So you will write AB square plus. Now this is right angle triangle CDE, where DE is the hypotenuse, the remaining two sides are these. So DC square plus CE square can be written as DE square. So CE square plus DC square I have written, and this can be written as DE square. Since triangle ABC and triangle DCE are right angle triangles, because this triangle ABC and DEC are right angle triangles, so this we can write. Therefore AE square plus BD square is equal to AB square plus DE square. Finally we could prove the given relation. Proved. Question appears to be very easy, but when you solve, all combinations you will have to remember, and accordingly you will have to proceed. Now we will go for the solution of question number 14. Question number 14 is perpendicular from A on BC of a triangle ABC intersect BC at D such that DB is equal to 3CD. Prove that 2AB square is equal to 2AC square plus BC square. What is given? ABC is a triangle. From A, perpendicular is drawn on BC at the point D. Then we have to find this relation. So for solution, here we are having two right angle triangles. With the help of these triangles, we will prove this relation. What is given? AB square. First we will write AB square. So here AB square is equal to, suppose we are taking triangle ABD, this is 90 degree, then AB is the hypotenuse. The hypotenuse square is equal to AD square plus BD square. So you will write like this, AD square plus BD square. This is the relation. And one thing it is given that BD is equal to 3CD, right? So you will write over here BD is equal to 3CD, and this BD can be written as BC minus DC. Therefore BC minus CD is equal to 3CD. Therefore BC is equal to 4CD. Therefore CD is equal to BC by 4. Because we want the relation AB, AC, BC, CD is nowhere. So I have converted this in terms of BC. Now BD who is over here, so AD square plus BD is equal to 3CD. So we will take up 3CD square. That is equal to AD square plus 9CD square. But we know this is also right angle triangle. So here AC square is equal to AD square plus CD square. Isn't it? This is right angle triangle. This is hypotenuse. The one side, another side is this. So AC square is equal to AD square plus CD square. So 9CD square is there. So you will take 1 with AD square. You will write AD square plus CD square plus 8CD square. So these two, if you take together, that will be AD square plus CD square. AD square plus CD square will be AC square. So you will write that is AC square plus 8CD square. Because AB is there, AC is there. AB is there, AC is there. BC is there. So in place of CD, we will write CD in terms of BC. So just we have found out CD in terms of BC is BC by 4. So we can write AC square plus 8 into BC by 4 whole square, that is equal to AC square plus 8 into BC square upon 16. 2 times it goes. Therefore AB square is equal to AC square plus BC square by 2. We can take 2 LCM and then we can multiply. Therefore 2AB square is equal to AC square plus BC square. This relation is now proved. So this way we have completed up to question number 14.